Figure 3 shows part of the curve with equation y is equal to 3 cos x. The point CD is a minimum point on the curve, with C being the smallest negative value of x at which a minimum occurs. And then we're trying to state the values of C and D. So to do this, we have to think about the transformations that have happened to cos x to make it 3 cos x. So let's say we have f of x is equal to cos x. If we do 3 f of x, this is then 3 cos x. This transformation here, when you multiply f of x by 3, that multiplies all the y coordinates by 3. It's a stretch of scale factor 3 parallel to the y-axis. So if we think of a normal cos graph, this coordinate here would have been minus 180 minus 1. But then, because we are multiplying the y coordinates by 3, then the d, which is minus 1, now goes to minus 3. This does not affect the x coordinates, it only affects the y coordinates, so the minus 180 stays the same. So then our answer to part A, C is minus 180, and then D is minus 3. For part B, state the coordinates of the point to which P is mapped by the transformation, which transforms the curve with equation y is equal to 3 cos x to the equations below. So following the same kind of logic, let's say now that f of x is equal to 3 cos x, which is our original graph that we had here. We're trying to transform that. So I'm starting with f of x being 3 cos x and then thinking about what I have to do to f of x to get these two things. So for part 1, you'd have to do f of x over 4. Whenever you replace anything in this bracket with something, then what happens is all of the x's in our function get replaced by what's inside this bracket. So this would then be 3 cos x over 4. So if you were to have f of ax, so basically some number multiplied by x within these brackets, that is a stretch scale factor 1 over a parallel to the x-axis. So in this case, our a is equal to 1 over 4. That's how we get x over 4. So therefore, this transformation represents a stretch scale factor 1 over 4, which is the same thing as 4. It's a stretch scale factor 4 parallel to the x-axis. It doesn't affect the y-coordinates, so the minus 3 does not change, but the minus 180 will. So the new coordinate for part 1, for B part 1, would be minus 720 minus 3. And again, that's just multiplying the x-coordinate by 4. For B part 2, so again, starting with f of x is equal to 3 cos x. To get x minus 36, we would do f of x minus 36, and this would be equal to 3 cos x minus 36. Again, replace the x in our function with what we have in the bracket. This is a translation of 36 degrees to the right. So whenever you have f of x minus a, this is a translation of vector a, 0. So a in the positive x direction, 0 in the y direction. So that means that this coordinate that we have, or the original coordinate, which was minus 180 minus 3, you add 36 to the x-coordinate, and it becomes minus 144 minus 3. And finally, for part C. So part C seems to be unrelated to the previous parts. We're solving this equation in the interval of 450 to 720. So 3 cos theta is equal to 8 tan theta. That can be rewritten. We can change the tan theta into sine theta over cos theta. I'll bring the cos theta to the left-hand side, so we end up with 3 cos squared theta is equal to 8 sine theta. So this is shaping up to be a quadratic. If we consider the identity, sine squared theta plus cos squared theta is 1, and rearrange for cos squared theta. Now we can replace the cos squared theta with what we have here, 1 minus sine squared theta, and we end up with 3 times 1 minus sine squared theta is equal to 8 sine theta. And the reason I did this is because if we expand this out, we then end up with a quadratic with sine theta effectively being like x. So I can bring all of this to the right-hand side just to make the sine squared term positive. So 3 sine squared theta plus 8 sine theta minus 3 is equal to 0. Put this quadratic in our calculator, so a is 3, b is 8, c is minus 3. And we end up with, to put it on the right-hand side, sine theta is equal to 1/3, and sine theta is equal to minus 3. Sine theta can't equal minus 3 because for a sine graph, the highest value is 1, the lowest value is minus 1, so minus 3 is all the way down here somewhere. The sine graph will never cross minus 3. Okay, so we're left solving sine theta is equal to 1/3. And if we look above, the interval is 450 to 720. So 450, theta, 720, and it is including 450, so I'll change that. Okay, so let's draw out a sine graph. Okay, so I've drawn it between 0 and 360. I know we're solving between 450 and 720. Because the sine graph repeats itself every 360 degrees, if we find the answers between 0 to 360, and then we can just simply add 360 onto those solutions to then get it into this domain here, 450 to 720. So 1/3 is over here somewhere. So sine theta is equal to 1/3. 1 is here. If I do inverse sine of 1/3, I get 19.47, which is down there. And then, using the symmetry of the graph, if I do 180 minus 19.47, I end up with 160.53. And I can do that because this angle is 19 degrees from the left-hand side, and therefore it should be approximately 19 degrees from the right-hand side, from 180. So those are my two solutions for theta in the interval of 0 to 360. 19.47, 160.53. Now neither of these things are in the interval, obviously, so if we add 360 to both of them, so 360 plus 19.47 gives us 379.47. That's also not in the domain. If I add 360 to 160.53, I get 520.53. That is in the interval, so that is our first solution. Now, if I were to add 360 again to these two values, it would be bigger than 720, so we stop there. And our final answer would then be 520.53.